Question 1 says that the time taken t minutes to complete a puzzle was recorded for each of 150 students. Total students are 150. These times are summarized in this table, and this is cumulative frequency. What it means that 44 also includes these 16, okay? And 86 includes both of them, the ones before that, which is 16 plus 40, 60. That's what we should be aware of. Draw a cumulative frequency graph to illustrate the data. What we do while drawing cumulative frequency graph, we take the upper limit, which is 25 in this case. Can I write this one as 0 to 25? It says 25 and less. So 0 is part of it, so 0 to 25, but we look at the higher upper limit, which is 25. In this case it is 50, in this case it is 75, and so on, and plot them with the frequency, cumulative frequency they have here. I have taken this graph, which is not the exam graph, but it is just somewhat like that. I have written the data on the lower part, which is the time taken. So let me write here, time taken to solve the puzzle, right? And I have also given a vertical scale here, which is cumulative frequency. So this has upper limit 150 because cumulative frequency is up to 150 and the data is up to 200. That's why this is 200 here. So now I will plot the points one by one. The first point is 2516, then it is 5044, and let me fast forward the video and connect those points. Okay, so we got this graph, and this will be the cumulative graph of this particular question. Let's talk about the B part. What is the B part of this? Use your graph to estimate the 20th percentile of the data. 20th percentile, it means 20% of the total frequency. Total frequency is 150. So we'll multiply by 150 and we'll get it 50 times 2, 50 times 3, 2 times 10, 30. So what it means is that if the data is in ascending order like this, the person who is at 30th position, yeah, will have 20 percentile. 20% of the people will score below him and including him. So we'll go to the graph now, and this is the 30th person's position. So we'll go to the graph here and come down. 20th percentile. Time is how much? 35 minutes. It is approximate, depends on the graph you draw. I drew a curved graph. Some people can draw a straight graph that will give a little different answer than this. But this is what it is all about. Let's go to the question number 2. And this is the question. 20 children were asked to estimate the height of a particular tree. Their estimates are in meters, are as follows. So yeah, everybody has different thinking. So they have estimated the height differently. Find the mean of the estimated heights. Okay, so we know mean is, which is a sigma x over n. That means sum of all of these divided by how many they are. They are already written that they are 20. So we know the denominator is 20. Now let's add them. 4.1 okay, there is 19.4 also. All right, so just use your calculator to add all these and find their mean. So the total of all the estimated heights is 123.4. If we divide it by 20, we get 6.17 meters as the mean height. There was nothing challenging in this. Only thing that could challenge that how carefully you entered these numbers in your calculator. Let's see what is B part. It says find the median of the estimated heights. For median, we need to arrange them in ascending order, and they are in ascending order. So again, they have made our job very easy. So they are 20. 20 is an even number, right? So whenever we have even numbers, just half it, which is 10, right? So whatever is the half, that number and the next number of that divided by 2. Find their means and you get the median. So what is the 10th number in this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5.4 is the 10th position. Next one is 5.5. And find their mean. That will give you the median. So it is 5.45 meters. That is the median. Okay, let's see what is it about the last part of this question. Give a reason why the median is likely to be more suitable than the mean as a measure of the central tendency in this. Okay, so can you see there's a big difference between them? So they're saying why. They've already decided, they've given us the hint that median is the better one. That means find out what is problem with the mean that is not giving us good picture. And the problem with this mean is that last number. Can you see the difference between the previous number and the next one? 6.9 and straight away 19.4. This 19.4 is an outlier. Outlier is a data which does not fit with others within that particular range. So because of this high number of 19.4, the sum, this 123.4, this sum got affected, and that's why it increased the mean by a lot. It is 6.9, it is almost 3 times. 19.4 is almost 3 times. That means this boy didn't have any knowledge about the measurements, and that's why he gave a very strange kind of data, outlier. So we'll write the mean is unreliable. What are they saying? Not suitable. Because data contains one outlier of very high value, which drove the mean upwards significantly. So median is more suitable. Yeah, because in median 19.6 is just a count, so you will go down normally. So even if it was 100, that wouldn't make any difference, and that's why median is a better choice. Question 3. The random variable x takes the values these 5, -2, 1, 2, 3, 4 rather. Okay, it is given that probability of every x is k times its own square. That's what it means. Let me give you an example. Suppose x is -2. So its probability x is equal to -2 will be k and -2 square. That's what this means, which becomes 4k, right? And this is how we'll go about it. Draw up the probability distribution table for x, giving the probabilities as numerical fractions. So we will draw a table like this, and this is x, which is -2, 1, 2, and 3. So here is the probability of x equal to x. So for -2 we already got 4k. Okay, for 1 we'll do the same thing, k times 1 square, which is just k. For 2 it will again be 4k, because 2 square is also 4, and for 3 square is 9, so 9k, right? But they said draw the probability distribution giving the probabilities as numerical fractions, and we are giving probabilities as in terms of k. They are not numerical fractions. That means we have to evaluate k first and then put it here. So we know that the probability of all x's, sigma of probability of all x's, is always equal to 1. That means 4k plus k plus 4k plus 13 plus 9, rather 9k, is equal to 1. These all add up to 1. So it will be how much? 5 plus 4, 9 plus 9, 18. K is 1. So k becomes 1 over 18. And now we will remove k's from them and write the numerical values. So it will be 4 times 1 over 18. And then it was k 1 over 18. It will again 4 over 18. And 9 times 1 over 18. So the finally probability becomes what? 4 over 18. If we cancel them, it becomes 2 over 9. And that fulfills our requirement. Probabilities as numerical fractions. 2 over 9 here. 1 over 18 was already there. This will be how much? This was 1 over 18, right? So it will be 2 over 9 again, and this 9 and this 18 cancel. 1 over 2. And now you can verify if you want to write, if 2 over 9 plus 1 over 18 plus 2 over 9 plus half is 1. Just make sure it is equal to 1. It will surely be equal to 1. This is the probability distribution table. Let's talk about the B part now. What is B part saying? Find the expected value of x and variance. So the formula for expected value of x is sigma x probability of x multiplied. That means multiply each x with its probability, and because sigma, add them, you get expected value. So we'll do that. X is -2 in first case, but its probability is 2 over 9. Then we have 1, its probability is 1 over 18. Then we have 2 times 2 over 9 and 3 times half. So it becomes how much? -4 over 9 plus 1 over 18 plus 4 over 9 plus 3 over 2. These two are exactly same with opposite signs, so they cancel out, and this will be times 9 times 9. How much? 1 plus 27, 28 over 18. Or if you want to convert it to decimal, we can divide 28 by 18, and it will be 1.555, that is 1.56 to 3 significant figure. This is the expected value of x. Second was variance, and the formula for variance, let me make some space for this. So variance of x is again sigma, this time x square times px, and multiplied by, so not multiply, subtracted the expected value we just got, it is square. We got 1.56, we'll write 1.56 square at the last, and before that, we will square every x and multiply with its probability. Here we did not square, we just multiplied x. But in this case, we will square. So it will be 2 square, negative 2 square rather. Its probability is 2 over 9 plus 1 square, probability is 1 over 18 plus 2 square, probability 2 over 9 plus 3 square, probability is half, and we already got this one. So 4 times 2, 8 over 9 plus 1 over 18 plus 4 times 2, 8 over 9 again, 9 over 2 minus 1.56 square. Let me use my calculator to find out the right answer. By the time I do this, I would request you to subscribe to this channel, like this video, share with your friends, and motivate me to make many more videos like this as I've been making. And this comes out to be 3.8997, which we will round out to 3 significant figures. 3.90. That's the variance. Question 4. Ramesh throws an ordinary fair 6-sided die, normal die, okay? Find the probability that he obtains a 4 for the first time on his 8th throw. That means this is geometric probability. So first time means he fails for 7 times, because 8th time he's getting a success. So first of all, we should have the probability of success, which we just write as P. Will be getting a 4, and getting a 4 out of the 6 faces is 1 out of 6. That means the failure Q will be 1 minus 1 over 6, which is 5 over 6, and he's for sure failing for 7 times. So probability that success on 8th attempt will be that the person will fail for 7 times, that will be 5 over 6 to the power 7, and get a success the 8th time. This is the probability we'll get, and if we use the calculator, we get 0.04651. Okay, no need to write 3 significant figures. This is the answer. Okay. Find the probability that it takes no more than 5 throws for Ramesh to obtain a 4. Same 4. Yeah. So again, the probability of success is 1/6. Probability of failure is 5/6. Now look very carefully what I'm trying to say. Find the probability that it takes no more than 5. That means the success is within 5 attempts, right? First 5 attempts. That means success could be the first. He gets a 4 on the first attempt, second attempt, third, fourth, or fifth, but no more than 5. For sure, the person gets a success in first 5 attempts, right? Can I interpret this as that Ramesh doesn't fail in 5 attempts? That means he gets a success, definitely. That means its probability no more than 5 throws. So no more than 5 throws. That means that he fails all 5 times is not the case. It means that he does not, for sure, does not fail all 5 times. Okay. So this is what we will put now in our calculator. 1 minus 5 over 6 to the power 5. And we get 0.5981. So there is no need to write 1. 0.598 is the answer. What about the next one? Ramesh now repeatedly throws two ordinary die. Okay, so that means it is not the case of the previous one, it is two dice now. Each time he adds the two numbers that he obtains. Okay, for 10 randomly chosen throws, 10 throws like this, that means he throws them 20 times, right? Two at a time. Find the probability that Ramesh obtains a total of less than 4 on at least 3 throws. So out of 10 throws, at least 3 throws, which means the successes are either 3, 4, 5 or till all 10 successes. These are the cases, right? So we can say that the ones which are not included, so not included successes, number of successes are 0, 1 and 2. These are the ones we don't want. We want 3, 4, 5 up to 10 successes, but not 0, 1, 2, and we'll take their help to get our answer. So first of all, we should know what is the probability of success, which is P. Okay, we want a total of less than 4. So what will give us in throwing of two dice, what will give us a total of less than 4? So less than 4, less than 4. That means we want a sum of 1, 2 and 3. How can we get a sum of 1 from 2 dice? We can't get it, right? Because at least we'll get 1 from 1 and 1 from 1, total 2 will be there. So we can get a sum of 2 but not a sum of 1. So what will give us a sum of 2 if both of them gave me 1? What about 3? For 3 it will be 1, 2 and 2, 1, right? These are the 3 possibilities which will be counted as success. And 3 out of how many? How many combinations are possible? There are 6 combinations possible from first and 6 from second. 6 times 6, total 36 combinations are possible from 2 dice. In other words, sometimes you might have done, we can make a table like this: 1, 1, 1, 2, 1, 3, right? Like we make a table and last one is 6, 6. So if you count all those combinations, they are 36. So 3 out of 36 is the probability of success, which is 1 out of 12, right? And now we want either 0 success, 1 success or 2 success, then we'll subtract it from 1 because they are not included. So what will be our answer now? P, that success, did we call X success as X? Okay, let's call it X. X is at least 3 throws. That means more than or equal to 3 is equal to 1 minus probability of X is less than 3. So we can write 1 minus probability of 0, X is equal to 0, or probability of X equal to 1, or probability of X equal to 2. Okay, so now we can convert them to binomial distribution because we want certain numbers out of 10. So it will be 1 minus, for 0 it will be 10C0. 10C0 is actually 1, no need to write, but for the formality we can write it. Success is 0 and the probability of success we just got 1 over 12. That means the failures are all of them. So we should find Q is 1 minus 1 over 12. This is the probability of failure, 11 out of 12. So 11 out of 12, all failures. Then 10C1, 1 over 12, 11 out of 12, 9, because this is 1, yeah? Plus 10C2, 1 over 12 to the power 2, 11 over 12 to the power 8. This power and this number must match, or this number can also match with the other one, but usually make it a habit of matching with this one, and their sum should be equal to the total number of attempts. And now we can carefully put all of this in my calculator, or you can put in your calculators, and we get the answer. The answer I got according to this is 0.04448. So 3 significant figures we can write 0.0445. Question number 5. Farmer Jones grows apples. The weights in grams of the apples this year are normally distributed. Standard deviation 25. Apples that weigh between 142 and 205 are sold to supermarket. Okay, so maybe rest of them they eat or whatever. It's Mr. Jones' problem, not ours. Find the probability that a randomly chosen apple grown by Farmer Jones this year is sold to the supermarket. That means it lies, its weight is between 142 and 205 grams. So let's try to visualize this. This is the normal distribution. Okay, this is the mean, which is 170. And suppose 142 lies somewhere here, which is less than 170, and 205 lies here, which is more than 170, and difference is 35 here and 28. They are not evenly distributed. Okay, so they're asking us to find the probability that it lies here. That means to find the area in this particular section. So what my plan is this: I will find this area below 205 with the help of the normal distribution table, because that table is for less than 205 only. Okay, then I will find the area less than 142, which is this blank part. So if I remove this blank part from the total area, I will be left with the one I want, right? That's what. For this, we'll have to find z scores first. So let's find z score for x is less than 205. And z for x is less than 142. The formula is x minus mean is 170, divided by standard deviation, which is 25 given. Same here, 142 minus 170 divided by 25. So this will be 35 over 25. 1.4. This will be minus 28 over 25, which is negative 1.12. Now we have to convert them to probability. Probability that x is less than 205. 205 is for z, and for z we need the table. Let's look at the table. And it was 1.4. So 1.4 is here, 0.9192. This is for probability for x is less than 205, 9192. Okay, similarly we have to find for other also, which is negative 1.12. So we'll find for positive, because there is no negative here, 1.128, 1.12886. Okay, now what do we do? Because our z score is negative, so we will do what? Probability x is less than 142. For negative, we write 1 minus, and whatever we got for positive 1.12. That's how we change it. So this will be how much? 0.1314. And our plan was to subtract this probability from this probability, and we'll get our answer. So probability that x is between 142 and 205 will be 0.9192 minus 0.1314, which is 0.7878 and rounded off to 0.788. That's the answer. Okay. Farmer Jones sells the apples to the supermarket at 0.24 each dollars for one apple. Okay. He sells apples that weigh more than 205 to local shop. Okay, okay. He doesn't eat them. Okay, at 0.30 each. He does not sell apples that weigh less than 142. Maybe uses with his family and eats them. The total number of apples grown by the Farmer Jones this year is 20,000. Calculate the estimate of his total income from this year's apples. Okay, so his income, let me write here. Income is from two sources: supermarket and local store. So he sold here at 0.24 and we got 0.789, right? Let's use 7878. He got 0.7878%, not percent, but probability is that it is between 142 and 170, and this is the rate at which those were sold at. So number, let me write here, number of apples sold at supermarket will be 0.7878 times total numbers were 20,000, right? Okay, whatever that is. So the income from supermarket will be whatever number of apples are there, 0.7878 times 20,000 times 0.24. This is the income from supermarket. So now we need to know the income from local store. So if you go to the previous question, we already know how many were less than 205. 0.9192. This percent of apples were less than 205, but we want more than 205 for this, right? So the probability that it is more than 205 will be 0.9192 subtracted from 1. This is the probability of more than being probability. You can write x is more than 205. This is the probability, right? Multiply this by 20,000. That will give you number of apples, right? And multiply by the rate at which each apple was sold, 0.30. Find these two amounts and add them. That will be the total income. Let me do this. You can do yourself also. So what I got for this is 3,781.44. And here 484.80, and if we add both of them, 4266.24 and if you want to round it off again to three significant figures, it will be $4,270. Moving on to the C part. Farmer Tan also grows apples. The weights in grams of the apples grown this year follow this normal distribution. Okay, the mean is higher. So his mean is 182. His apples are better. Standard deviation is 20. 20 square is variance. So 20 is standard deviation. 72% of these apples have a weight more than W grams. Find the value of W. So let's again visualize it. Mean is here 182. Since 72% are more than W, right? Yeah, more than W. So W is here, that means. And we should keep in mind that it will have a negative Z. Yeah, because it is less than 182. And this is 72%. Okay, so let's do what? We'll take care of the negative later. Let's say that there is a reflection of W here which is positive. Let's find probability of that W prime. Okay, for 72 degrees, because this area will be 72 under W prime. This will be 72 degrees. Let me find Z score for this, and I will give that Z score to W because I know it's negative. Just put a negative before that. So I need the table again. 72% is the probability. So 7190. Can you see here 7190? It is 0.58 and we need 10 more. 3. 0.583 is our Z score for W prime. So that's what I'll do now. So here the Z score is 0.583, but this was not our question. Our question was W. This will be minus 0.583, and this is where we will use probability that X is less than W is negative 0, not probability, it's Z score, negative 0.583, and this is equal to the W, which is the value of X here, minus mean 182 divided by the standard deviation, which is 20. So this is of use for us, and we will use only this. So cross multiply first. Minus 0.583 multiplied by 20 is equal to W minus 182, and we will put this 182 here and 182 added here as well, so that W is left alone. And now we'll put this in our calculator and we'll get our answer. 182 plus minus 20 times 5, 0.583. We get 170.34. So value of W is this, and we rounded it off to 170 grams. Moving on to the next question, which is number 6. Sajid is practicing for a long jump competition. He counts any jump that is longer than 6 meters as a success. Okay. On any day, the probability that he has a success with his first jump is 0.2. Okay. For any subsequent jump, the probability of a success is 0.3 if the previous jump was a success. That is important. Okay. And 0.1 otherwise means if it was a failure. Sajid makes 3 jumps. Draw a tree diagram. Okay. So let's draw the first jump. Let's write first, then second, and third. Draw a tree diagram. So only tree diagram is needed. So first jump, it will be either success or failure. The probability of success is 0.2 for the first jump, and it will be 0.8 for a failure, because the sum of two branches coming from the same point must be 1. Second jump, because the first jump is a success, the next jump, the success probability is 0.3. And the failure will be 0.7 again, sum should be 1. Because the first jump was a failure in this branch, the success percentage probability is 0.1, failure will be 0.9. Third jump, because the previous one is success, the success will be 0.3, failure will be 0.7. The previous one is failure now, 0.1, 0.9. And again here, because the previous one is a success, 0.3, 0.7. And finally here, 0.1, 0.9, you know what's the reason. And that's it. We have to draw only the tree diagram. and 2 marks for that. Okay. What is next? Okay, too far. Find the probability that Sajid has exactly one success given that he has at least one success. Okay, so we have to use this formula if you remember. If not, write it. Probability A given B is equal to probability A intersection B divided by probability of B. So A in this case is, find the probability Sajid has exactly one success. This is exactly one success is A. And B will be given that he has at least one success. At least one success. Now onwards, I will call it A, I will call it B, and I'm focusing on B first because that is a bigger set, and A intersection B will be a subset of this probability. So probability of B at least one success. So we have to look at the branches where we have at least one success. So first one, failure, failure, failure. No, this is not. Failure, failure, success, yes. Failure, success, yes, yes, yes. In all these branches, there is at least one success. So we will have to add all these branches alternately. We can find this branch which is not part of it and subtract from 1. So probability of B will be 1 minus 0.8 multiplied by 0.9 multiplied by 0.9. All failures subtracted, we'll get these 8. No need to add them separately. And what will that be? 8 times 9, 72 times 9 is how much? Okay. Which comes out to be 0.352. Now we have to look at the intersection of A and B. In out of these 8 branches, in which branch we have exactly one success? Success, success, success. No. Success, failure, success. No. Success, success, failure. No. Success, failure, failure. Yes, this is the one. Yeah. So the probability of this one will be 0.2 times 0.7 times 0.9. Next branch, failure, success, success. Nope. Failure, success, failure. Yes. So this is the second branch. And this, I'm writing it somewhere else here. Let's write here because we have to add them. They got 3 branches, right? No, 2 right now. 0.8, 0.1, 0.7. Okay, third one. Failure, failure, success. Yes, this third branch is this one. This one. 0.8, 0.9, 0.1. Let me write here. 0.8, 0.9 and 0.1. These are the 3 out of 8 where we have exactly one success, and that represents the intersection of the 2, common between the 2. And that's what we are going to write here. So PB was 0.352. So let's write probability A given B will be the sum of these 0.8 times 0.9 times 0.1 plus 0.2 times 0.7 times 0.9, 0.8 times 1 times 0.7 divided by probability of B, which is 0.352. And now just put this in the calculator and we get the answer. It comes out to be 0.072 plus 0.126 plus 0.056 over 0.352 and finally 0.7215 over 0.722. Let's see next question. On another day, Sajid makes 6 jumps. Find the probability that only his first 3 jumps are successes or only his last 3 jumps are successes. So we can write this as like this: first 3 jumps successes, and they're saying only, that means others will be failure. So success, 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 failure, 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 or plus only his last 3 jumps are successes. Okay, success, 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 failure, 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 only last 3 jumps success. Okay, so we have clearer picture here now. If we go to our tree diagram, we'll look for success, 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 that branch, and make next 3 as failures. So this is the branch. The first branch is success, success, success. That means if I go to the next one, the probability of failure after success will be what? Success after failure is 0.3 because I'm not interested in success next. So it will be 0.7, right? Now, it's a failure. I want next also a failure. Look at the branch which is a failure and next again a failure. It will be 0.9. And failure, again a failure will be 0.9 again. So this represents us success, 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 S, 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 F, F, F. And the probability will be 0.2. We'll start with this one. 0.2 times 0.3 times 0.3 times 0.7 times 0.9 times 0.9. Okay. Now, failure, 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 and success, success, success. This is what we want. And for that, we go to the last branch. This one, failure, failure, failure. If the previous one is failure, what is the probability of success? Look at somewhere here. Look, this is failure, and then we have success here, so 0.1. Now we have previous one success, next one success is 0.3. Again we want a success 0.3. So the probability will be this branch now 0.8 multiplied by 0.9, then 0.9 again, 0.1, 0.3 and 0.3. This is my workstation for next questions answers. So I will take this and copy and take it somewhere else. So this one is 0.010206 and this is 0.005832. If we add both, because one of them will happen, right? There are 6 attempts, either this will happen in 6 attempts or this for our probability. So answer is 0.016038 rounded off to 0.0160. Question 7. A group of 15 friends visit an adventure park. The group consists of 4 families and they have given the details here. The group traveled to the park in 3 cars. 1, 2, 3, there are 4 families. One containing 6 people, one containing 5 and one containing 4. Okay. The cars are driven by Mr. Lizzo, Mrs. Martin and Mr. Nantes. Okay. In how many different ways can the remaining 12 members of the group be divided between the 3 cars? Okay, every exam has one question that in which you have to read between lines. or imagine things. This is one of those questions. So, since they have not mentioned Mr. Lizzo, Mrs. Martin, and Mr. Nantes, are they driving their own cars or any cars? Because suppose there are three cars. Okay, Mr. Lizzo is here, Mrs. Martin is here driving the car, and Mr. Nantes is here. If it is, let's assume that they are driving their own car. They're not practically, people don't drive others' car, right? They're driving their own car. If they were driving any car, then it would be multiplied by 3 factorial, which we will not do now. We are assuming that they are driving their own cars. Alright. Now, second problem is that the first car should have 6 people, right? And one driver is already there. We will ask 5 people out of those 12 to fill this car so that it becomes Mr. Lizzo and plus 5, that makes it 6. Then there are 7 people remaining out of 12. 5 are in this car, 7 remaining. Out of those 7, we will select 4 and ask them to sit in this car. They will become 5 here. Okay? And then remaining, if you don't want to write, it's okay because 3C3 is 1. Remaining 3 people will take 3. So if you write this or don't write, it's okay. But now the confusion starts here. If there are 6 people here, Mr. Lizzo and 5 more people, Mrs. Martin and 5 people could have been here also. This car could have had 6 people, this would have 4, this would have 5, another situation. They're saying in how many different ways. So they have not talked about the capacity of the car, so the car can take only 6, only 5, only 4 people. So in that case, we'll have to multiply this by 3 factorial. Because this 6 selection of 5, 4 and 3 people can be interchanged. And that's why the number of selections would be 1, 6, 6, 3, 2, 0. If people don't think about this, the answer would be something in 20,000s. That might be okay, but this is what extra I'm thinking. If it is wrong according to a marking scheme, please pardon me. Let's go to the next one. The group entered the park by walking through the gate at gate one at a time. Okay. In how many different orders? Okay, different orders. We want orders. Can the 15 friends go through the gate if Mr. Lizzo goes first and each family stays together? Okay. So the first entry has been taken by Mr. Lizzo. That means his family will follow him. So Mr. Lizzo is in second family. So he has family, Mrs. Lizzo 1 and 3 children 4. So 4 people will follow him, but those 4 people can come in 4 factorial ways. Correct? Then they will be followed by one of the families, remaining 3 families, right? So which family comes, we don't know. So those 3 families can come in 3 factorial ways, right? Now we will select each family. So this will multiply with this. First family, now you can take anyone. We have taken care of their order here. So let's take Mr. and Mrs. Nantes. So 2 factorial. Then Mrs. Martin and her child, 2 factorial. And Lizzo family is already there. So there are 4 children and 2 parents, 6 factorial. So our number of orders possible are 4 factorial times 3 factorial times 2 factorial times 2 factorial times 6 factorial, which will be 4, 1, 4, 7, 2, 0 number of orders. Okay. Let's go to the next one. In the park, I think we'll need this again, so let's keep it here. In the park, the group enters a competition which requires a team of 4 adults and 3 children. Okay. In how many ways can the team be chosen from the group of 15 so that 3 children are all from different families? Yes, we needed this. So we'll take 1 child from these 4 children of Mr. and Mrs. Caie. So 4C1. Then we'll take one child from Mr. and Mrs. Lizzo's family, 3C1. They have 3 children, right? And then we have one child, which is 1, from Mrs. Martin. So this is for the children. Now, we need 4 adults out of how many adults? 1, 2, 3, 4, 5, 6, 7 adults. 7, and out of those we will select any 4, and this becomes our group of teams. So it will be 420. Let's go to the next one. In how many ways can the team be chosen so that at least one of Mr. Caie or Mr. Lizzo is included? Whenever you have such a situation of at least one, do the opposite. Don't select them. That means exclude Mr. Caie and Mr. Lizzo. And we'll subtract that from total number of selections. Now, this first line, in the park, they're making this number of teams. This C is not part of D anymore because it's a different question. That means we can select 3 children from any family. It is not part of C. So we'll do what? We'll select any 3 children first. So how many children are there? 4 plus 3, 7 plus 1, 8. So 8C3. 3 children will be selected from these 8 children, and Mr. Lizzo and Mr. Caie are not included. That means there are how many? 7 adults, so 5 adults left. Out of those 5, we have to select the team of 4 adults, right? And keep it. We have to subtract this from total number of selections. So 3 children from 8 multiplied by 7 adults, and we are selecting 4 out of those. So these are the total number of selections possible, and this is without Mr. Caie and Lizzo. So let's take 8C3 common from both, and 7C4 minus 5C4 will be the total number of selections where they are included, at least one of them is included, and it will be 1680. This concludes this paper 53 of May-June 2022. Thank you for watching. If you like this video, please subscribe to my channel, like this video, share with your friends, and let me make many more videos like this for you. Thank you very much.